theoretical physicists are notoriously good at building models that seem compelling to human beings. And I think this is one of the things that often goes wrong in science communication when someone who came up with a model is the one doing the communication, because it is very easy to make these models seem correct because you can make them seem compelling. But there are 99 or 999 other models for which you could create an equally compelling argument or story as to why this model is correct. Now, eventually, of course, observation rules the day and models make predictions, and the ones that make false predictions get ruled out. But when you're dealing with a field like cosmology, where you have this problem that you can't create experiments, you can just observe what's there in the sky. But also, when you've reached a stage where the science is sufficiently advanced that in order to make new observations, you can't just, you don't have citizen scientists with their telescopes in their backyards anymore observing stuff. You have billion-dollar experiments putting things in space. You have tens, 20s collaborations of people, or 10 or 20 people analyzing the results of telescopes on Earth. You have collaborations of hundreds analyzing the results of telescopes on Earth. It's not so easy to gain the data that will rule in or out models. And inflation is especially difficult here because it happened very, very early in the universe, but it makes it even more difficult. So you can't tell the difference by observation yet, which model is correct, but you also can't tell by theoretical reasoning because we're easily persuaded and it's not necessarily true that some line of reasoning leads, like, the history is full of, at least scientific history is full of very compelling models turning out to be wrong. So even if there's some model of inflation that is more compelling than others, it's not therefore definite that it's true. So what one can try and do instead is take an entire framework. So here inflation would be the whole framework, and say, what fundamental principles do we think must be satisfied? And then go from there and say, if this principle is satisfied and inflation is true, what observational consequences must there be? And the idea behind this is that therefore any model that is constructed to fit the framework of inflation and that satisfies this fundamental principle will also make this prediction. And if it doesn't satisfy that fundamental principle, then either it's wrong or that fundamental principle is wrong, and it would have to then sort of explain why this fundamental principle doesn't work.